Hello. Hello, hello. All right, I'm rounding up the people in the back. All right. People in the back. Yes. All of you people who see me walking around with the microphone right now, except for you, Yang. Everyone else, to the front, to the front. Hey, hey, hey. Let's move to the front. Please move to the front. Hey, hey, Anna. Hey, please move to the front. Hey, guys. Everybody, please move to the front. Hello, group of people out here. Please move to the front. Hey. 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 What's your name? Sephro? Sephro? Stepho. Stepho, please move to the front. All right. Everybody's very spread out today, I guess. There are seats on this side still, if you would like to sit onto one of the cushions. Why do I still hear speaking in the back? This message is targeted specifically at you two. It's time to move to the front. What are you reading there, Krista?
Second book of the alphabet.
Oh, interesting. You studying how to do magic?
Yeah.
Way better. All right. I think enough people have migrated from the back to the front. There are a few people who are still out there, but I think this is good. So, welcome everyone. Hello. Hello. Wave back to me, guys. Come on. Show me some life. Yes, yes. All right. I'm really excited you guys are all here. Today we've got 4 different 15-minute talks and then 10 2-minute demos. How many of you guys have been to one of these events before? Okay, a few of you. So everyone else is new. Everyone else is your first event. If it's your first event, have you seen me before? Has anybody seen me before despite this being your first event? Colin, thank you. I've seen, you've been to many events. Okay, Great. So I'm getting more famous. So make sure that you scan this code and help me reach my 100,000 followers on LinkedIn. I'm about 91,000 away, so hopefully you can help me make that 90,000. Other orders of business, if you are looking for a DevRel role in SF, I'm helping some companies hire for DevRel and SF. So if this is something that interests you and you have a computer vision background or you have a background in LLMs and observability, scan this QR code, fill it out. It's pretty simple. And if it fits, we'll be in touch. You guys all found this event through Luma, right? Okay, I think you guys are all subscribed to the calendar, so I'm going to skip this. Next month, we have another event, October 7th. I'm going to put this up here, and I hope that you guys all scan this and you guys all come to the event next month. If not, I'm going to put it up again at the end, and hopefully you guys all come to the event next month at the end, and you like the event enough that you'll come back. Okay, other than that, I have nothing more to say. Oh, actually, you know what? I'll give my cliche speech. Okay, so I always talk about this. Like, why do we host these events? You know, what is the reason behind this event series? So this event series is called Awesome AI Dev Tools. And the goal of this event series is to be helpful in getting all developers access to the resources to understand, use, and contribute to the development and direction of AI. So hopefully you get something out of this, whether it's something that helps you use more AI products, whether it's something that helps you understand products, or if you scan the DevRel role, hopefully it's something that allows you to contribute to that mission. So thanks for being here. I'm going to kick it off and welcome our first speaker, Vishaka.
Let me connect. That's always a good start. So now I have a tough job. I have to wake you guys all up on a Monday with a database talk. So let's try and make that happen. So how many of you here work on machine learning applications? Okay. How many of you work with databases? Any kind. How many of you build databases? Oh, good. There are a few. Let's talk afterwards why we brought this on ourselves. All right. So today what I'm going to talk about is ApertureDB. So I'm Vishaka. I am founder of ApertureData. And our database that we've been working for a really long time is called ApertureDB. And in some sense, I feel like I've been on this multimodal data and AI journey since as long as I can remember. So I want to take a different tactic today. Usually I go about like, oh, all these people have these problems, and this is really the problem, and this is why we are awesome. But I wanted to start with an example today. I just picked a simple example of, let's say, the queries that you have to implement, or your use case, is to find faces. You want to find face images matching Scarlett Johansson. But not just find similar faces. You want to go further and build it with find people who look like Scarlett Johansson, but also with dark brown hair. And also maybe specify some movie. So ultimately what we are trying to do is we want to implement similarity search constrained by metadata, some complex metadata filtering, and followed by image and video access. Now, how many of you work with images and videos here? Okay, so even if you work on documents, text, whatever I say here, you'll be able to apply and take the same lessons and work in the similar manner with our database. So now, the data set I'm going to refer to, it contains a bunch of images. It contains annotations on those images. So if you see, you have facial features marked on there. There are videos. And And that's truly a multimodal data set. You're talking about different modalities. It's not just images, not just videos. It's annotations. It's metadata that describes the faces. And that's what we have to implement that use case on. So now let's see how you would go about doing it today. You start out with the input data. You want to go out for data to display here on the right, on that side. So of course, you'll take the images, they'll go in some cloud bucket. You'll take the metadata. So there is metadata about brown hair, black hair, all that information about all of those images. You'll take that and land it in either a relational database, maybe a graph database, or a key value store. Maybe you realize the annotations require some work, so you'll have some labeling. And so you have to share those images in buckets with your labelers, or maybe you have to share it wherever your IDE lives for labeling, and then take the annotations back and put them to make it searchable. And after that, you start writing scripts. You write queries. You need to talk to 3 different systems at this point. Maybe to display, you have to pre-process your images, or you have to shrink them in size. You have to sample the videos. And then finally, we all hear so much about vector databases, but in the grand scheme of things, that's where it goes and fits. You had to go through all of this before you got to the point of indexing your vectors to be able to do similarity search to find the faces. Now so what we are talking about, and this is just for a very simple use case. So this data point is more for a real world deployment. But what can happen is for any use case, you can end up needing a lot more data and platform engineers. Imagine instead of the 200,000 celebrity face data, you had 1 million, 10 million, 100 million of these images and videos, and you had to implement all this stuff. It just takes a really long time to implement that spaghetti diagram and make it functional in production. So I'm going to show you an alternate way of implementing this with ApertureDB. First, of course, you start with ingesting data. Now, if you go on Kaggle, you have the celebrity data set, and you have all those different metadata values. You have image IDs, you have different features about the faces. And all you do in ApertureDB to ingest the data is you use a command line, ingest it, and if you see those lines with transformers, essentially what we are saying is as you are adding images, introduce these other new properties. So let's say for every image that you're ingesting, you want to enter metadata about how wide, what's the height of the image, what's the width, what's the resolution. So you enter all that by just putting a transformer there. And the second transformer, we are saying, as you are inserting images into ApertureDB, along with all that metadata that you got from Kaggle, go ahead and put embeddings together with it. So in that one line, what did we create? We created a schema that not just has images with different metadata information. We ingested descriptors or embeddings. And then in another line, you can ingest annotation information. And this is how very easily you get metadata, images, embeddings, labels, all of them in one database. What does that help you do? Let's go see. Through a simple dashboard, you can see everything that's available in your database after you ingest those images and information. We see all the properties, their types. You see all the connections and objects that we have. So I'll come to why I'm talking about objects and connections in a minute. And now let's say you want to find people with black hair. All you do is go on the UI, put a constraint, and you can very easily see images there. Now, you want to find faces resembling Scarlett Johansson, or at least we want to let FaceNet try its best. Don't blame me for the matches. FaceNet does a terrible job. But all you have to do, if you look at the line, you just say find similar images, pass it an embedding, and you can track down the number of images that match those constraints. If we wanted to combine vector with metadata search, all we did was introduce some metadata constraints along with similarity search. Remember, we inserted metadata and embeddings along with images in the same database. So, of course, you can use both of them together to find the data that you're looking for. In fact, one of the things we also did was to index embeddings extracted from a clip model. from OpenAI. And that allows us to do multimodal search, where you say enter search term. OK, I just entered Asian woman just to see what it returns. And it gave me pictures that match that. So I was able to index image embeddings. I was able to index multimodal embedding. You could search just by a vector similarity search. You could search by text. In fact, you could do annotation searches. So here what I'm saying is I want to find images where right eyebrow intersects with hair. And you get pictures that match that criteria. And here we are searching by annotations. Just one more example here. I wanted to find videos that were ingested in the same database. And I put, well, I want ADB data source equal to some criteria there based on metadata. And I can fetch videos. In fact, I could have gone and processed these videos to skip every 5th frame or resize the videos, and it would all be one query. So how are we able to do all of that in one database? That's why ApertureDB is special. We built it to understand not just the challenges introduced by multimodal data, but also to fulfill the requirements of the entire machine learning pipeline. And that's why what we built it with was with native support for multimodal data like text, PDFs, images, videos. We've been working with computer vision data for a long time, which is why you see certain operations supported better in ApertureDB, but essentially you can store any sort of data in Aperture. Then we store the metadata in a memory-optimized graph database, which is how you can build your knowledge graph pretty easily on ApertureDB. And then the third component there is a vector DB, because very often you can find data just by searching for similarity. And the beauty of it all is because of that API that ties everything together, you can blend the graph and vector search behind one API. So as a user, you are only ever talking to one database that gives you a capability of using all of your data. And that's how we can be the unifying backend for multimodal data. We can enable multimodal search and display. We can enable data set management, and then there are things that you can do when you're working with AI pipeline. But essentially, the ApertureData difference is to make use of all your data across your entire machine learning workflow and achieve the results you're looking for from your AI efforts. And in fact, lately, this messaging has become even more important, especially as everyone is trying to kind of deal with, what's going on in the AI industry. So we are happy to have some be trusted by AI teams at some of our customers. But we often get a question: why did you have to build another database? And really, if you look at the top, the various steps you require for your entire application, not just a search, not just one step of it, but the entire application. And you look at all the offerings that you have available, that's when you realize there are things missing which force users to have to build that spaghetti solution unless something is purpose-built for this sort of applications. So that's what we do at ApertureData. We have a launch coming up, and we have some exciting, if you want early access to be able to build interesting applications and win some prizes, please scan the QR code and sign up. And I look forward to hearing from you. I don't know if you have time for questions.
Questions? No questions. Oh,
that was a lot of information in short time.
Just a small one, actually. You mentioned that in the second last slide, I think there was a diagram showing the training, inference, all the pipelines as the output. How does that happen? Like, is it like a snowflake type of interface where like on-premise execution can happen, or is it on cloud? What's the integration type, and what type of fine-tuning training approaches can be implemented?
Yeah, so what you saw was essentially each one of those steps interacts with data and metadata in some ways. And so we have integrations. For example, we have integrations with PyTorch, TensorFlow. We have integrations with labeling tools. We have integration with things like LangChain. So all of those tools can query data from ApertureDB. And ApertureDB itself can be deployed on-prem, in VPC, and we have a cloud offering. So you can use our community Docker edition to build applications as a prototype, or you can try it on cloud.
Time for 2 more questions. Any other questions? All right.
Thank you. I'll be here after the event, so we can talk then.
All right. Thank you very much, Vishaka. Our next speaker, Anna Robakitsi, please come on up.
Hello, everyone. I'm Anna, founder of Theneo, and today I want to tell you about the story of how we build our own language model. We were the first one in the API ecosystem, and a little bit about our 3-year journey. So, a little bit about Theneo, what we do. We are essentially Copilot for Stripe-like API documentation. We are backed by Y Combinator, Atlassian. We support a lot of different formats. You can upload your API specification, and in just seconds, you have that Stripe-like API documentation. So why did we even start working on this? Back in 2021, when I was working as head of engineering, I was working on thousands of APIs. As an engineer myself, I absolutely hated writing documentation. And especially hated others' documentation when it was not done correctly. So, and I looked at Stripe's documentation. I loved it so much. I thought there could be a way I could also have the same quality documentation, not just how it looks, but also the quality of it. But I'm not a technical writer, and not every company can get into technical writers, especially for internal-facing documentations. So we thought, okay, why not generate our own model that could take care of all of it? So back then, there was not ChatGPT available. There were GPT open source model, but there was no API that we could use and integrate all of this. So we had to build our own. So this was a side project for some time, and then I applied to Y Combinator, and they asked us to quit our job. We did, and here I am. So, and then in March of 2022, we launched our AI model. And so, like I mentioned, there was not really a lot of options. So what were the models that we were considering? We were looking at open source models, from GPT open source models to T5. And for us, one of the biggest challenges was, okay, on top of like choosing a base model that worked for us, we also needed to come up with the data that we could train on. So I'm not going to go into details how you can choose base model and all that. I know all of you are very technical. But the reason why we decided to go with T5, because it was very efficient for us, and all the kind of comparison that we did compared to other models, for us in our use case where we were just feeding API spec and wanted the output of the documentation, it worked really well. So, but the complexity came actually with the data. And the reason being is because first we looked at all the open source and publicly facing documentations we could find on GitHub with API specs. And most of them, to be honest, were horrible because they didn't even have the basic descriptions, let alone the full descriptions and good quality data set. So then we started looking at the public-facing documentations. Obviously, Stripe has a good one, but there is other ones, right? We looked at those. Then we started hiring technical writers so they could help us generate a good quality golden data set. Then our users grow also, so we were training on the public-facing documentation in Theneo. I'm going to skip all of these because I know all of you are very technical, so it probably will bore all the details. But so this is how it looked like essentially. So in our editor, you would run AI Assistant, and it would generate the descriptions. And you'll see here that there are 3 different descriptions. And the reason being is because we were actually running 3 different models, and we wanted to compare which one would perform the better, which ones the users would select. Also, we would look into not only which one you would select, but also which one you ended up using in production, which one you would change a little bit and things like that. So we were continuously improving our model based on this, even though it was a little bit annoying in the beginning because you had to choose the description itself, right? But we actually demoed this at TechCrunch Disrupt. Has any of you been at TechCrunch Disrupt? There you go. It's very exciting. You probably have seen the episode at Silicon Valley, like everyone is pitching, etc. And like we got amazing feedback. We were so excited. Others were excited about this as well. And then just 1 month later after this, ChatGPT comes out. And we were telling investors that, hey, look, like this, creating all this for our competitors, like especially bigger competitors, putting all this infrastructure will take them forever. Like we already have this, etc. So we thought if our competitors could not do anything close to that. But ChatGPT came out, which means that anyone could use their API and do what we were doing, right? But we were looking at it, see, hey, can we actually integrate ChatGPT? So we came up with AI search, so you could ask the questions inside the documentation, which is not really anything extraordinary today because a lot of other platforms have followed, but we were the first ones that have created the Ask AI feature inside the documentation. And then also we realized that our users didn't want the product just because of the AI element, and it was just the other features and the whole suite of features that they were coming for. So what is the value of proprietary model, and would we use ChatGPT if we were to start today? Or would we create our own model? And to be honest, most likely today, if I were to start Theneo, I would not create our own model because 1, it's very expensive, right? It takes a lot of time. And in order to validate or do some kind of product testing, I would use something like ChatGPT or any other models that we could first understand how the users would use it and maybe in the future use a proprietary model. But today, it does give us a lot of flexibility of how the model behaves, and also with enterprise customers that we have, that plays a huge role because not all the enterprises can use or want to use OpenAI, and also because we do self-hosting, it goes really well into their pipeline and remove some of the data privacy issues as well. So I really want to quickly show you how it looks like today. So you bring your spec. It can be anything. We support from GraphQL, Async API, Postman collection, Insomnia, obviously Swagger, and all these things. So I'm going to upload here a spec, and this is where our own AI writer comes in. If you don't want us to create anything additional content, you can just simply select No AI Assistance, activate AI search. You can have internal-facing, public-facing documentation, and we can also automate your entire flow. So our editor, so everything is already generated for me now with all the API endpoints. And our editor works same as kind of Figma or Notion. So if you have multiple people here, you can live collaborate together. It's a lot of fun. You can even make changes to your APIs as well, from descriptions, additional properties, and things like that. Unlike other platforms where you have a lot of limitation, in Theneo you have barely any limitations. You can change and configure the content however you want to. In regard to AI system, this is how it looks like today. So it will run the through hole, generating the descriptions, header, request body, responses, everything. I can either individually select like this and will generate the description, or I can apply and I have all the descriptions for me, so it saves a lot of time and I don't need to bother any of the technical writers for this. Once I'm done with all of this, I can either review with the team or just publish it. This is how the published version looks like. You have everything, most of the content that you are seeing here has been generated by our own AI with all the descriptions. I don't know how well you can see in the dark mode, so maybe this would be the only place where light mode could be applicable. You can also test it out, the APIs in real time as well. Obviously, ask AI the questions, anything that you want to. And in terms of testing, it is designed for anyone to test it out. Even non-technical people can very easily just run the API. They don't even need to go back to the documentation. They can get all the information in one place and just quickly run it. One of my favorite features is actually automatic changelog. So one thing also I hated is making sure that changelog was always up to date and writing all the release notes in a way that was also very easily accessible to others. So now we take care of that entirely. We write the entire release notes for you, also highlighting what was changed, what were breaking changes, which was deleted. So it's very easy for your readers to follow all the changes that are going on. They can enter their email and also receive email notifications, so there is never a question what's going on with your APIs and when was it last updated. So this is all when it comes to the documentation, but we also do developer portals, and creating developer portal is as simple as just so with documentation. So here's an example with Swap. Everything that you're seeing here from the user guides, APIs, release notes, all of that have been generated in Theneo, which it took them just a couple minutes. Again, we have so many different templates. And you can use the Theneo for API catalogs, all the different use cases. You can authorize them. And most importantly, also, you can collaborate with your engineers as well and have the automation in a way that you want. So right now we have we're going to hit very closely soon 12,000 companies that use Theneo. And the reason why we grow so fast is because of communities like this. So we want to thank everyone. And if you're interested, you can scan this. You can try out our latest version before anyone else can. And for those that will share your thoughts on social media, you will get, for the most engaged users, you will get $200 gift card from DoorDash and other credits from Theneo. Thank you so much.
All right. I also hate writing documentation. Okay. Any questions? Any questions for Anna? No questions about documentation. Oh, okay. Suddenly 3 people raise their hands.
So just to make sure you got this right, we're still using T5, right?
Yes.
How is it doing compared to GPT-4, for example, or in this use case specifically?
So initially when we compared when ChatGPT came out, we saw in so many different ways that it was outperforming us, which was obvious. But the thing is that because we have very niche data set and we've been training on very specific use cases with API specs, and also it turns out that we had a lot of data in a fintech space. So we outperform even today when it comes to fintech cases and
Amazing.
Documentation. But for other cases, let's say agriculture tech and very other specifics that we don't have enough data, I would say ChatGPT performs better.
I have a lot of questions.
Okay.
How do you detect breaking changes between code and spec and then show them in the changelog?
So we have our own predefined rules that right now they're just defined for you. And very soon we'll also allow our users to add your own rules as well. But the breaking changes are the ones that are very basic, that everyone would kind of universally agree that those are breaking changes. For example, if you make optional field required and things like that. But very soon you'll be able to add your own rules and configure them as well.
So my question is, let's say, so how does the collaboration work between developers? For example, if I make a change in editor and my developer makes change in GitHub, for example, how does it work?
So a lot of our users would be different type of, like there will be product managers, there will be technical writers, there will be engineers, and everyone works differently. For example, product managers obviously love going to the web editor, collaborating there, making changes. An engineer might not ever go to the web editor, and they will be deploying through our integration with either GitHub, Bitbucket, we have our own CLI tool, SDK tool, integration with Atlassian, like Compass, etc. So there are many different ways that developer can push the changes without impacting whatever someone else did in the web editor, because we have different merging algorithms that we are able to detect and make sure that we deploy in a way that you want to.
Do you think you'd do better if you took your data set and just fine-tuned GPT-3.5 on it, or GPT-4?
Good question. The reason we haven't done it is because of our ego. I don't think we would survive that. But good question. Maybe one day we'll give it a try, but not today. After Series A, maybe.
All right, time for one more question. Does anyone else want to ask about docs? Docs, or Theneo, or Anna, or light mode, dark mode?
I'm going to be around, so if you guys have other questions or if you want to see more use cases, feel free to.
Cool. Well, thank you, Anna. All right, our next speaker, Brian Johnson, should change his name to Justin. Justin, for just in time.
Yes, thanks. Thank you. All right, let's plug this in. Not coming up with an option for the screen. It's the same talk. Yeah. Okay, yeah. That'd be great. Apologies. I spilled water on my laptop yesterday, and so I'm using like a different laptop than I normally use. But Eugene's gonna grab his. He has the presentation on it from last time. Thank you so much. Okay, thanks. My name is Brian, and I'll be talking today about conversational video interfaces, and in particular, the challenges of making it fast enough that it feels like a natural conversation. And so this gets to the question of why is real-time conversation hard? One of the reasons is that humans actually talk really fast in conversations. The delay from one person to the next is very short, and I'll get into that a little bit more. First, my name is Brian Johnson. I'm a father, a husband, and an engineer for over 2 decades, and currently I'm staff engineer at Tavis, where we do conversational video interfaces, among other things. So first of all, we decided to solve this problem by building our own fully end-to-end stack to do conversational video. And the reason we did that is because we wanted to be able to deliver the best experience possible. And in order to do that, it needed to be really fast. And so by bringing everything into our own stack, we're able to control as much as possible and make it really fast. We also wanted to be really flexible, so we made it so that we can allow people to replace specific parts of the stack. And I'll talk a little bit more about what the stack looks like. But overall, we deliver a video, audio, end-to-end solution where you can talk to a digital replica, and it uses an LLM, TTS, and all of those goodies under the hood. Okay, and this is a little bit more about that. And so we've got what I'd say right now is the world's fastest audio video to audio video interface. It's under 1 second, and we've seen it as low as 600 milliseconds in real world measurements. It's hyper realistic and plug and play. And so this is the reason why I'm giving this talk, and that is that it has to be really fast. So in normal conversations, and a lot of research has shown this, the time between when one person in a conversation stops talking and the other person starts talking can be incredibly fast as 200 milliseconds in a very good conversation. So in the cases where we're having a great conversation, you and me, if you actually measured the time between when I stop talking and when you start talking, it's going to be 200 milliseconds, which sounds really fast, but if you pay attention to it, it's actually quite normal. There's been a lot of research that shows this. In fact, a lot of times people actually interrupt each other, and so the modal is actually 200 milliseconds, but sometimes it's up to like a second, and sometimes as early as 1 second before the other person's done talking. Okay, and in addition, it also takes us about 700 milliseconds to think of what to say. So if you put all this together, this is a really hard problem to solve, to be able to respond so quickly. So how do we do it? Well, first of all, there's all these pieces to a conversational video interface. First, it's visual. You can actually see somebody. Audio, it actually sounds like someone. It can see you and hear you. At the same time, it has some knowledge, so like LLMs, think LLMs. It's logical. It's kind of holding a temporal sort of sequence of events. And it's also interactive or interruptible is how we like to think about that. So we have this thing, we call it Carter. You can go right now to Tavus.io, and you can try our demo on the site. And live, you can just sit there and actually talk to the replica one-on-one. We got #1 product of the day on Product Hunt, which was kind of cool, the day we launched. Oh, and I have a little demo. And
this is a really cool experience. What do people tend to ask?
I'm actually not going to do the demo right now, though, because I don't think I have time. Let's see. Where did the thing go? Sorry, Eugene. Okay. So one of the other big difficulties when you're talking about speed is that video is way bigger than audio. And you've seen a lot of demos probably about voice-to-voice. That's pretty hard to do, have a really quick response time of 200 milliseconds. I haven't seen very many that have done that. But then if you throw video into the mix as well, which is 10,000 times the size of audio, it gets really difficult. And so what are some of the tools we used? I'm just going to quickly go over these. This is the list of tools that we use to apply to our conversational video pipeline to make it faster. A lot of this should probably be pretty obvious if you're pretty deep into engineering. If not, I'll go through these really quickly. And the first one here is streaming. Streaming is the idea of sending as few bytes or as few frames of data as you possibly can to get something visible to the user, to get some first interaction or some first visual. We apply streaming throughout the entire pipeline at every stage, from streaming in audio, video from the user to streaming it to an LLM, into an LLM, or streaming it out of the LLM, because you can't really stream into an LLM, streaming into a TTS and out of the TTS, and also streaming back to the user. So not streaming is kind of slow, quick little demo there, and streaming is much faster. Okay, let's see if I can get through these really quick so I don't have to spend time on these. Sorry about that. It's n times faster. So the less you can send, the smaller the chunks you can send, the faster it is to that first interaction. The other thing we had applied is parallelism. So there's all these 6 steps or whatever going on, like multiple things going on at the same time. If we can not have to do those in sequence, but do them kind of at the same time, it's going to be faster. Super obvious. Here's a kind of a diagram of all the different steps that are going on inside the pipeline. And you've got things like speech detection, audio buffering, text, speech to text, chatbot or LLM. Then you have sentence endpointing, text to speech, replica inference, and then streaming on both sides. And then there's a little visual question answering. So parallelism, super important. And here's what it looks like if you don't do parallelism. and what it looks like if you do parallelism. So you're doing multiple things at the same time simultaneously, but they're still going in sequence. So that has n times throughput. Now throughput is not latency, so throughput won't get you all the way to having under a second utterance, but throughput will allow you to not run into a barrier of how much you can send. So you're not going to end up buffering that first frame because you have a high throughput. You're able to send through that first, second, third frame without running into your limits of what you can send. So the higher the throughput doesn't necessarily get you faster latency, but there's a throughput where if you're below that throughput, it will increase your latency because you can't send enough data to render a single frame of video. The next thing is kind of like multitask. I'm going to skip through that because I think parallelism covers it. And then the final thing the final kind of category is putting things into memory. One aspect of that is in CPU memory. Another aspect is into GPU memory. So without putting things into memory, you're kind of transferring things one at a time. And you get this video frame, you transfer it over. You get another video frame, you transfer it over. This is from the inference side of this. But if you keep all those video frames, the source video frames in memory, and the source data in memory, you can basically pass around a pointer to whatever you need to reference at a given time. This may not make a lot of sense if you're not familiar with our pipeline, but just know that originally one of our challenges was having to load things from the disk or keep things in CPU memory or well, those were the only two other really options. And we ended up putting things into GPU memory as much as possible to speed them up. And that got us from like 1.5 seconds it trimmed off about 1.5 seconds of latency from our response times. GPU memory, same story. The idea is that the further away your data lives, the further it has to travel, and that traveling takes time. So if we can move all that data into the GPU, we're faster. And we saw like a 4x speed up from this, from going from 15 frames per second to 90 frames per second. Now our data renders at a natural 25 frames per second, which means every 40 milliseconds we have to deliver a frame to the user. And so we need to be rendering faster than that by quite a significant amount in order to keep up with it and to keep up and keep a smooth video output. All right, so what's next? We have we've brought on board quite a few customers, and the things that we've heard about have actually changed since this presentation. Our boot times are now around 2 seconds, modal 2 seconds, from when you make an API request to when the video conference room is available and the replica is there ready to listen. Our utterance to utterance times are anywhere from 600 milliseconds to about 1.3 seconds. And it's interruptible. We have events and observability going out so you can actually know when the replica's talking, when the person's talking. You can get information about what's happening in the conversation when people join and leave. And then we also have an API where you can do this all through like a REST API. It's pretty easy and pretty quick, and you can check it all out at Tavis.io. The big lessons on speed are to separate things thoughtfully. I think initially we separated every single thing into a different process, but that introduces a ton of overhead and complexity and then ends up with extra latency because you're not coordinating things as fast as possible. And then the second part is to try to keep reusable data in memory. Don't let it fall out of memory, keep it in memory, reuse it as much as possible. And then break things into smaller chunks when possible. And that's that. And so the idea is that by making it really fast, it feels more realistic. And if you go give it a shot, you might experience this. When you're talking to a replica that responds really quickly, it feels a lot more like you're talking to a real person. Not that that's what we're trying to do, but it feels more natural, more ergonomic. When you have to wait, you start questioning things. Even if it's like 2 seconds or 1.5 seconds, you start to think, is this thing going to respond? Is it going to come back? Like, is it broken? And so being fast really makes a big difference because that's what we're used to. Some use cases are things like Nike.com. What if you could go to a website and on the website, Michael Jordan appeared before your Nikes and was guiding you through the process? We also recently introduced function calling into our LLM layer, so now you can do things like change the web page or order the shoes that the person is asking about. That's all up to users of our API to do, but we make it possible through function calling. Here's some other use cases: sales rep, customer tech support, and tutoring. Our customers really love us. We're very developer focused. So if you're a developer and you want to build out an application with this kind of AI, please reach out. We'd love to hear from you. We'd love to help you have a really great experience building the interface so that you can focus on the user problem and building out the business domain. And that's it. That's my talk. You can check us out at this URL. Thank you. Thank you. And are we taking questions, John? Yeah. Okay.
All right. Any questions? Any questions? Don't everybody raise your hands at once. I literally said not to do that.
Nice talk, first of all. And you mentioned parallelism and task, and both are the same, or not? Because I was a little bit confused as you mentioned both. So I know that parallelism is parallelism, and you have different tasks that you are doing it in parallel. But why you put these two together? To differentiate it both.
Yeah, so that's a really great question. The question was, aren't tasks and parallelism the same? And the answer is yes, they are. And in fact, I don't know if you heard me at the beginning, but I spilled water on my laptop, so I lost my updated presentation. This is the old one. But yes, that's a very good point. And I kind of looked at that when I was re-editing it and was like, yeah, these are the same. So I don't think there's really a lot of difference there. And I'll be a little transparent. Some of this was me editing this presentation down because originally, when I made this, it exposed a lot of internal details that I kind of wasn't sure I should really be getting into because those things change. And so when I renamed it to tasks, that kind of ruined that and combined those two deeper details together. So it's totally a good feedback. Yeah, go ahead.
How big should be a chunk, by the way?
So we're down to anywhere from 3 to 6 frames of video as a chunk. So that's kind of how we break it up by frames. And so we've got a frame of audio that goes with a frame of video. And we're trying to get as close to 1 frame as possible. So if you think about it, our natural video play rate is 25 frames per second. So it's 40 milliseconds per frame. There's also some like latency and render time that goes with each one of those. So if you multiply 40 times just 4, you've got 160 milliseconds. And then you got to also render it. So you got to play that out because you need to play through it. Then you need to also render it. That might take 100 milliseconds. So you're talking 260 milliseconds right there. You can't get to that 200 millisecond modal if you have 4 frames with our model. So we want to get to 1.
Cool.
Megabytes?
Other questions?
Yeah.
All right, thanks for the talk. I was really interested in the replication, because I think there was you were talking a lot about the audio and the understanding and interoperability, but there's also the video side of things. And how do you you have to merge them, right? You can't have the video be first or the video be last and then the audio be. So you could talk more about that process of merging audio and video.
Yeah. So our model takes in audio and spits out video. And so it takes in a window of audio, and then it basically figures out a frame of video from that window. And then we have to get the amount of audio we need for that video frame. And then at the back end, we have to sync back up the audio and video together and send that down the rest of the pipeline together, and then send them out at exactly the same time. And this is a very interesting detail, is that when you're doing streaming, WebRTC is one of the technologies available to you. And it's all about timing. It's all about sending the video frame and the audio frame at exactly the same time. We have a partner, their name is daily.co, that we're using, and they're really helping us they helped us to figure that out. They're a great partner and a great service. I definitely recommend you check them out.
So I guess over the course of a conversation, your customers are probably going to have context that's like relevant context that's changing quite a lot, right?
Yeah.
And that's going to be coming from their own systems, via RAG or something. How do you handle that at the moment, or like, do you handle that?
So we have an LLM layer that you can customize. It's OpenAPI or OpenAI spec, so it matches OpenAI spec. If you have your own LLM, even if you don't, and you just want to intercept that layer and then put an LLM with RAG behind it, you can do that with our setup. We do have our own LLMs. We have 4 different LLMs we offer. We have one that's incredibly fast right now that we offer. It's using Llama 3.1. And we're doing 8B, and we will do 70B soon. But you can also bring in your own LLM. In fact, most of our early customers do that because they came to us with an LLM that was already pre-trained, pre-ready to go, and so they just plug their LLM into our conversational video interface, and they get like an audio-visual layer on top of that LLM.
Does that often affect latency, though?
That actually introduces a bit of extra latency. So it really depends on how fast the LLM is, but even with the LLM we ended up using, it's over a WebSocket connection or an HTTP connection. So you can have it be incredibly fast if your LLM is set up that way, because text is actually super small in terms of the size. If you're co-located in terms of your data center, you can get down to like 30 milliseconds of latency for that first byte to be delivered. And then it's a matter of how fast you can spit out tokens. But yeah, you can see really fast times even with a custom or LLM, but then it becomes your job to tune that up. And we can help you with that because we've done it already.
Cool, thanks.
Thanks. Have you ever thought about like predicting and caching potential things that'll come up in a conversation? Because I know, every meeting probably has like at least 75 phrases that are like commonly repeated. Like, hey, let's circle up after this. Like, you could probably have tons of these things like running in the background with an LLM that's just like, based on this conversation, come up with a few things that might be said and then cache responses.
So the question is, could we just pre-render the responses to some degree and just use that? And we definitely, and the question was, did we think about that, or have we tried that? We haven't tried it. We do have one canned response, actually, which is the initial intro, which is programmable. So you can always have like the same intro if you want. But like everything after that is rendered on the fly. And it was mostly out of initial effort to reduce complexity, like to minimize the amount of complexity. So we just wanted it to be really fast and do it kind of the same way every time initially. That may be like an optimization we do in the future. If there is like an external LLM that's a little slower, for instance, we might offer someone the ability to kind of send out sort of like an indication of an initial phrase, like yeah or nah. The challenge is that you still have to interpret what someone's saying, and that is in order to like say the right thing or the appropriate thing. If somebody says, "Oh, I just wrecked my car," you don't want to go, "Yay," And so the fact is, the later parts of our pipeline, the TTS and the visual rendering, are really quite fast. We're rendering at like over 100 frames per second on the video, and the audio latency is like 70 milliseconds on our TTS. So that part's not really the hard part. I think the harder part is actually figuring out when the person's done talking, streaming out the LLM, figuring out when sentences are done, and then those are actually really the hardest parts, those two parts. Yeah.
Cool. Last question.
Thank you. Okay.
First of all, great talk. Two questions actually. Like the first one being that have you ever experimented with multimodal models instead of stitching together the models like LLMs, then text to speech, or maybe speech to text also in the beginning?
Yeah.
What's the output like in comparison?
Yes. So the question is, have we experimented with multimodal models? And that's a great question. We do actually. Our video model is actually multimodal. It takes in audio and spits out video. So that's about as far as we've gone so far. We are currently researching deeper multimodal, and eventually our plan is to have the whole pipeline be capable of being multimodal. So voice audio in, voice audio out, and in one model altogether. But we're not there yet.
Cool.
Yeah, that's kind of one of the goals. Yeah. Yeah.
Okay.
Thanks.
I was going to say we wrapped up on questions. I know there's a lot of questions, so Brian, you'll be here after. Yeah. So if you guys want, you can mob Brian later.
Yep.
But for now, we gotta go to our next speaker.
Thank you.
Connor Gallagher. Connor, where are you? Connor? Do we have a Connor Gallagher? Ah, there he is.
How's it going, everybody? My name's Connor. I build stuff at Cookbook.dev. We kind of aggregate a bunch of smart contracts. What's that? Oh, sorry. We aggregate a bunch of smart contracts, a bunch of libraries, a bunch of developer tools, and put them all into like one kind of centralized place for Solidity developers. I can speak as a Solidity developer, like finding all the stuff to work with networks and kind of like just hit the ground running. There's always kind of like some friction there. So that was kind of the first thing we set out to solve. After we started like showing Cookbook to people, and especially at hackathons and talking to networks, we kind of realized that the ROI on developer relations in blockchain is like this unknown number. Like nobody knows what it is at all. People dump like millions and millions and millions of dollars into hackathons and into just kind of getting people to exponentialize transaction volume on their chain, which is what Solidity developers do in EVM-based chains. So we kind of asked ourselves, like, what's the best way to approach this? Like, how do we take the tool sets that we have? How do we take our AI assistant? How do we take like the ton of data that we have as far as smart contracts are concerned and networks? And how do we assist developer relations teams in being like far more successful and really understanding like exactly what they're spending and how effective that is? So this is our site, but I kind of wanted to walk you guys through how we kind of create a demo for these teams through our internal tool. So I was just going to put in like base. We'll do a demo for base right now. And then let me just add a... There we go. And save. Okay. So this generates an API key for me, and my portal has been created. This CMS is available to all the teams and of our partners that have integrated us into their documentation sites. And I can just show you real quick. I'm just going to drop this API key in here. Sorry, it's a little funky doing it with one hand. And I'm just going to save it. Git add A. Git push. Sorry, base. Okay. Fuck. Git push. What is it? Sorry. Base demo. Okay. All right. So, well, that's cooking up in Vercel. I'm just going to show you guys the CMS itself. So what's cool is The first thing that we have here, we haven't used the bot yet, so we can't see, but I'll come back to this. But this is essentially where all the questions are going to come in that are being asked at the documentation site. This is the kind of general appearance. So DevRel teams can come in and kind of customize this and make it look more like their site. They can have a prompt that they put in there. They can add a pretext prompt. They can add suggested questions to start the bot off. And then we're going to click Playground, as well as add base's URL ID, and just save that right now. And so you can see here that base demo is deployed, and I can just come over here and check it out. And you can see Ask Cookbook, our little modal, has popped up, and we have our AI assistant. We have the chain info for base, which basically has everything you need: block explorers, official links, bridges, bounties, grants, faucets, wallets. You can connect your MetaMask here to all of their networks. Total value locked. The metrics are provided by DeFi Llama. And then we have a playground as well, which is kind of like a half IDE. It's really just to look into our library that we've provided here, which has a bunch of contracts from our site, as well as you can edit the code here, you can compile it, and then you can, of course, deploy it onto testnets or mainnets or whatever you'd like. We also have Open and Remix and Chain IDE, and you can download our custom boilerplates for Foundry, Hard Hat, or Scaffold ETH. So yeah, that's kind of like what the CMS, that's kind of like our product for documentation sites. And as far as the CMS is concerned, you can also, like I said, you can mess with the appearance. You can kind of update it to make it look more like the site itself. And then a fun thing that you can do is you can really add as many data sources as you want from our library of data sets. If you go here, this is our demo for base as it is right now. And you can see that we have some some loaded questions that their team asked us to, or added in to the CMS themselves. You can see that it's kind of looks a little more like their site, and fits into the background a little bit more. But ultimately, that's that. But ultimately, what we're building right now at Cookbook is a way to kind of aggregate a lot of these questions that come in through base, or let's just say Manta Network, because they're live partners of ours right now. Uh-oh. And it's frozen. 1 second. Sorry about that. Oh, boy. God damn it. There we go. So you can see questions that have been asked about an hour ago on Manta. Now, the DevRel team can go through here. They can improve the bot response. They can thumbs up it. They can thumbs down it. And they can also actually go in to their data source and into their library and say, okay, well, I want to add these new sources, or maybe these links are old. They can also refresh their data sets whenever they would like. And these are also on auto refresh every 24 hours. Our scraper and indexer, proprietary indexer runs and repopulates our databases and our vector database with their data. So yeah, that's kind of like the product end-to-end as it is right now. And on a roadmap coming up, we're going to be taking a lot of the feedback from the overview and pairing it with on-chain data. So we can both see what are the pain points that these networks are having as far as onboarding developers, where exactly is that happening in their documentation, and then on top of that, and more importantly, how is developers visiting their documentation site, how does that translate into on-chain transactions? Like, if somebody looks up an ERC20 on base, using A, B, and C, like, a proxy or like, I don't know, whatever it may be, where exactly are they doing that? What questions are they asking? And how do we kind of like form this kind of like digital identity of each user to understand like what is your common user asking, what are the pain points, and how are you guys able to address this at this point, at your documentations at this point? And our bot itself is really designed to not like hallucinate. It's not really meant to answer questions that it doesn't know the answer to at all, very intentionally. And as far as code generation is concerned, we keep it very, very light because it's ultimately a liability to a lot of partners, and with Solidity, it's just not it's not trivial to just like generate code and be like, yeah, deployed on mainnet, good luck, enjoy. We're very specific about like how we retrieve context, how we filter it with metadata, and some of the pretext prompts. Our whole RAG data flow is very proprietary and very concentrated on being extremely specific and minimal, because we've found that that makes teams the happiest. But at the same time, having a very deep knowledge of Solidity and the EVM, which we've found other like competitors like, well, I don't know if I should name any names, but like other people who are doing this in the Web3 space, they are usually for both Web3 and Web2, so their knowledge is very iffy at best. And that's where like a lot of our robust data sets like come in handy quite a bit. So yeah, that's kind of the product end to end. That's kind of the roadmap for us. I'm trying to think of it. Yeah. But we're Cookbook.dev. That's pretty much what I have for you guys. If you guys want to open it up for questions right now, does that work?
All right. Any questions?
So about how advanced do I need to be to dive in and start using this? Because it seems like a pretty advanced tool. So where do I have to be in my process to use it?
Well, as far as the website or the documentation, you really could just hit the ground running. Like I always tell people this. When I started Solidity deving years ago, if Cookbook existed, things would have moved a lot faster for me. The thing that I love about our bot, especially on our site, is each contract is like very strictly its own context for that particular bot. So it knows it in and out. It is provisioned with just information on that particular contract and that particular situation, and any sort of EVM versions, any networks or EVM versions that particular contract is using, like it knows all about that. And that's super, super tricky when you're first starting, is understanding the nature of the EVM, different opcodes that are available on Ethereum versus Base, people who don't use push zero, for instance. But yeah, so I think you don't need to know much. Honestly, we could get you deploying an ERC20 in less than 10 minutes.
Thanks. Also, what LLM are you using under the hood?
What's that?
What LLM are you using under the hood?
Oh, GPT-4o, yeah, right now.
Awesome. Yeah, so I guess when I was looking at it, you have the Cookbook.dev, which is like for the developers.
That's right, yeah.
And then now this is like the CMS, so this would be...
Yeah, so thanks for the question. That's a really good question, actually. So Cookbook.dev is our free and always will be free product. It's for devs, are saying is LFC, let's freaking cook. So we are all about developers. We build from the developer back to us, and not the way around, not the other way around ever. And we don't plan on charging them. What I showed you with the CMS, that's attached to deployments like, I mean, I could go to like Manta right now. Let's just go to Manta Network, and you can see us. That's us on their live site, Ask Manta AI. And so this is a suite of tools we call Cookbook Onboard. And so Cookbook Onboard is meant to be, the entry point, I suppose, is like a docs bot kind of thing, but the real product is like a DevRel suite. It's really like trying to get networks to truly understand, okay, so this is what people understand, this is what people don't understand, and this is how it translates to on-chain transactions. This is how it translates at the end of the day to the volume that transactions are coming in and the worth of the actual network altogether, because Solidity developers are what exponentialize transactions on blockchains. That's EOAs are great, and people are like, oh, when we adopt consumers, like when consumerism comes to blockchain, like, it'll be a whole new level. But truly, like right now, the users are devs, and so yeah, that's kind of our thesis. And we're not looking to replace DevRels. We're not looking to do any of that. So yeah, long-winded answer, but this is our DevRel suite, which is Cookbook Onboard, and its kind of entry point is the DocSpot, and then our free product is Cookbook.dev, which is for all developers to use whenever they would like.
Got it. So it's like the extension or the I guess like the bot is then on their front page website, and then that's how you're getting the like inbound questions and stuff like that.
Exactly. Yeah, exactly. And it's also how like DevRel can just start really understanding their users on a deeper level, for sure.
Awesome.
Thank you for talk, but if to be honest, I lost a little bit in the beginning. So when you said smart contract and provided all this information, can you please describe more use cases of your product? I want to better understand what the point of all of this.
So use cases for our product as far as what's concerned?
For customers. So I'm doing this something, what kind of problem it solves?
I mean, ultimately, what this product is for smart contract devs. I mean, it is very much for smart contract devs. I'm not sure if I'm understanding your question.
Yeah, I know what is smart contract, but describe me use case. So I agreed with this guy about something. So we decided, okay, I do something for you, you will pay me, and we put this information in smart contract. It's how I understand smart contract. So it is use case. So I said, I'm done part of my work, pay me. So, and he said, yes, work is done. I click submit, and some cryptocurrency put in my account.
So you're asking what are the use cases for smart contracts?
Yes.
Okay. Different question. I got you. I mean, that's a really, really big answer in my book, just because I'm a nerd for smart contracts, but they could be used in so many different ways. Smart contracts obviously are an incredibly robust financial tool, which you pretty much just described there. But they're also used to kind of, one of my favorite things that are developing right now is like kind of like a way to have an encrypted permission on different services. Like I think with Telegram mini apps especially, like there are all these cool little apps coming out right now where you can buy like an NFT that's not like a piece of art or something like that, but it's more like a country club card, right? And like imagine if you could buy an NFT that got you into like the Silicon Valley Telegram, and like, could like chat with Zuckerberg and like all those other guys. Like I think that's a really cool use case for it. But honestly, yeah, you're right. Like financial primitives, like new exotic financial primitives, that's the most exciting part about cryptocurrency, for sure. And I think that products like this are really interesting because you have a lot of people in TradFi who are truly interested in authoring smart contracts. I've talked to a bunch of them, like in hackathons in New York and stuff. And there's actually this one guy from Goldman Sachs that told me he used Cookbook to like basically learn Solidity in like less than a month for a project at work. So what I think is interesting is like Solidity is so weird and niche that like products like this are great because maybe you don't want to learn Solidity super deeply. Maybe you don't want to spend a lot of time doing that. Maybe you're a Python guy and that's what you've always been doing, or you're Rust or whatever. Like products like this allow you to kind of like just get through the pain points of understanding like how to build, how to deploy, the overall concepts, and just kind of hit the ground running so you have your back end deployed to the blockchain, and then you can just go back to what you're familiar with. Yeah.
All right. I love seeing a mix of two very new technologies. Now we're going to take a break before we get into the lightning round. This is one of my favorite parts of these sessions. We're going to see some amazing 2-minute demos. Thank you for the talk. So everybody, grab a drink, go to the bathroom, take a break. We'll be back in about 5 to 10 minutes.
Dreams begin to flow, lines and digits glow. Watch these wonders grow. Bright screens light our way. Innovate and play. Algorithms dance in this great expanse. AI minds unite, turning dark to light, from thoughts to bites in the still of night. Together we create, no paths we navigate, in the silence find the future we define. With every click and key opens what could be. Visions come to life, cutting like a knife. AI minds unite, turning dark to light, from thoughts to bites in the still of night. In the world of code, dreams begin to flow, lines and digits glow. Watch these wonders grow. Bright screens light our way. Innovate and play. Algorithms dance in this great expanse. AI minds unite, turning dark to light, from thoughts to bites in the Dreams begin to flow, lines and digits glow. Watch these wonders grow. Bright screens light our way. Innovate and play. Algorithms dance in this great expanse. AI minds unite, turning dark to light. From thoughts to bites in the still of night. Together we create, new paths we navigate. In the silence find the future we define. With every click and key, opens what could be. Visions come to life, cutting like a knife. AI minds unite, turning dark to light. From thoughts to bites in the still of night. In the world of code, dreams begin to flow, lines and digits glow. Watch these wonders grow. Bright screens light our way. Innovate and play. Algorithms dance in this great expanse. AI minds unite, turning dark to light. From thoughts to bites in the still of night. Together we create, new paths we navigate. In the silence find the future we define. In the world of code, dreams begin to flow, lines and digits glow. Watch these wonders grow. Bright screens light our way. Innovate and play. Algorithms dance in this great expanse. AI minds unite, turning dark to light. From thoughts to bites in the still of night. Together we create, new paths we navigate. In the silence find the future we define. With every click and key, opens what could be. Visions come to life, cutting like a knife. AI minds unite, turning dark to light. From thoughts to bites in the still of night. begin to flow. Lines and digits glow. Watch these wonders grow. Bright screens light our way. Innovate and play. Algorithms dance in this great expanse. AI minds unite, turning dark to light. From thoughts to bites in the still of night. Dreams begin to flow. Lines and digits glow. Watch these wonders grow. Bright screens light our way. Innovate and play. Algorithms dance in this great expanse. AI minds unite, turning dark to light. From thoughts to bites in the still of night. Together we create, new paths we navigate. In the silence find the future we define. With every click and key opens what could be. Visions come to life, cutting like a knife. AI minds unite, turning dark to light. From thoughts to bites in the still of night.
All right, everybody in the back, if you want to come watch America's Next Top Model, we're starting. Presenters, where are you? All right, let me call the presenters. Thak Win? Here? Okay. Yev Spector. Is there a Yev Spector here? All right. Caleb, I saw you earlier. Caleb you're Yev Spector. Great. Okay. Please be ready. Caleb, okay, please come to the side and be ready. These are going to go real fast. There's just 2 minutes. Vivek, I saw you earlier. Where are you? Okay, you're ready. Ahan. Okay, you're also ready. Okay. Andy, I see you right there. Meghna. You're ready. Okay. Ibek. You're ready. Okay. Vaibhav, you're going last. Vaibhav, are you here? I know you're here still. Okay. There's George. George, you're going 10th. 11th? No. You're going 10th. I'm getting these in order. Okay. All right. What is your company? Stackback. Okay. I'm gonna have to write this down. What is your company? What? Laminar. Okay, cool. So I'm going to put you guys down because I didn't write this on the site. So there's, okay. You'll be after Stackpack. All right, everybody in the back, if you would like to hear about all of the hottest startups, should come out up front. All right.
Oh, hello. I'm Roxanne from AnyShift, one of the co-founders. We are an AI search engine for your cloud infrastructure. So we are going to help DevOps, SRE teams find information in their cloud way faster. So, for instance, like instead of going to the AWS console, multi-regions, multi-accounts, how with our search engine you can find back resources and their code definition, infrastructure as code definition in the code base. So let me show you a quick demo. So just to give you some context, imagine you're a developer and you're actually searching multi-region, multi-accounts for a specific resource with a specific question. So we have like an NLP ChatGPT powered search. So let me actually do a specific question, something I want to find. So list, I like this example, list elastic cache, sorry. Resources with a security group in a specific region, which would be EU West 1. And actually, with AnyShift, we are going to translate the specific question to request with specific filters, and you're going to find, oh, there is an error. Oh, so this is a live demo. Let me search again. Normally, you should find am I connected to the Wi-Fi? Yes. Okay, perfect. So here you can see the specific security group which was found, the linked Elastic Cache cluster, and here, if actually you go further, you can find back the definition of this specific cloud resource in the code base. So here you can find that this Elastic Cache was defined in the Terraform module, and if you click on it, yeah, module definition, and you would find here the specific line in your repository where this Elastic Cache was found to save you a lot of time in terms of search and debugging. Thank you.
Awesome. Next we have Millis AI.
All right. Hi, everyone. My name is Tak from Millis AI. And we are a platform for developers to create advanced voice agents with super low latency of 600 milliseconds. At Millis, we believe voice will be the main interface between human and AI in the future. And we're focusing on two main challenges of conversational voice, handling conversation flow and the latencies. So our agents are able to handle interruption, detect end of turns, understand human intents, and respond, all with very low latency of 600 milliseconds. If you are in the US and you use English, it can go down to like 400 to 500 milliseconds. So we provide an easy plug-and-play API. You can basically integrate with any API to expand the agent's capabilities. In this demo, I can show you how it connects to my calendar using Cow.com APIs and to get the availability and handle the booking. Yes, I have a few questions about the API. It's rocky. Let me think. I think I can do it tomorrow.
Can you hold the microphone to the computer?
I can do 3 in the afternoon. Yes, and I can check my booking list to see like it's available now. That's all. Thank you. Check it out, meelist.ai.
Awesome. Great demo. Next, we have Jolt AI.
All right, awesome. Thanks so much for having me. I'm Yev, founder of Jolt. We have 2 minutes, so let's get into it. At a high level, Jolt is an AI coding tool that helps engineers ship code faster. We're designed specifically for existing medium and large code bases. Jolt can go through, modify over 10 files, and write over 1,000 lines of code in one task. It's really great at picking up and matching your existing patterns and conventions. And whether you're using chat or the code gen, we always have full code base context. And you're probably wondering, okay, there's a lot of AI coding tools out there. Where does Jolt fit into the picture? And you can think of it as the first step in a coding task. So let's say you're an engineer, you get a task assigned to you. First, you run it through Jolt to do the bulk of the coding. And then after that, you do the last mile of coding manually in your IDE or use something like Cursor or Copilot. And then once you're done with that, finalize the code, test it, and create a branch and submit the PR. So for the example today, I'll show you how we're going to do, we're going to add a Slack webhook integration to an existing code base. It's a mono repo, so in the front end, we want to add that Slack webhook URL to team settings, and on the back end, we want to update all of the types and models, and we'll create a new notification service that we can hit. So I'm going to skip straight to the implementation plan step for the sake of time, but usually it would take about 60 to 80 seconds. So what Jolt does before going straight to the code is it'll create this file-by-file implementation plan that tells you, all right, this is how Jolt is going to approach the task and what it's going to do, almost like pseudocode in every file. So you can see here it went through maybe a dozen or so files, and the plan is totally editable. So if Jolt is doing something you don't want or you had a different idea in mind, you can change it, you can add files, remove files, etc. So just think of this as the game plan for the task. And then once you're ready, you hit that write code button, and you can preview all the code changes directly in browser. I'm going to jam through this.
Wow. It even did the right code for the glue, 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 glue.
Yeah. All right.
All right.
And,
thank you very much, Yev. Next up, we have CodeScan AI.
Hello, everyone. I'm Caleb from CodeScan AI, building CodeScan AI. I believe everyone here is an engineer, right? So we write code every day, we build, and we're building features every day. But something that we sometimes ignore is the security of the code we're writing. We always want to make sure that whatever code we put into our production systems are, not susceptible to cyber attacks and like potential security vulnerabilities, and that's where CodeScan AI comes in. So at CodeScan AI, I'm building a product of a tool whereby, you can always test incremental code changes to your production systems to make sure that you are not making bad coding practices or less than standard coding practices that will potentially open your code base or your production system to potential security vulnerabilities. So I'm just going to dive deep into a demo. Currently, it's supported in different forms. You can have it like as a Python package, but right now I'm going to demo it as in your GitHub workflow. So, for example, say you have I have this test pull request, and say you want to create a pull request, and this is just a simple code that queries the database using SQL, and you create this pull request, and automatically we run the CI/CD workflow. It is like automatically ran. It's part of the current repository workflow, and it's a GitHub action basically. And this current code scan AI action. And then what this does is look through the code changes you've introduced into this pull request, and it analyzes it using AI models and give you like a report of things you should do better or ways you can improve the security of the code you're introducing into your code base. So that's what, if you look through this, you see that's all what it does, and it goes through, install the package and everything, and then adds it as a GitHub action, as a GitHub comment to your comment. So when you go back here, maybe I have to just reload this, and then you can see the results. And then this is a live demo, so this basically tells you how your code can be very vulnerable to SQL injection. It lacks input validation and other like potential ways, and also gives you like snippets on how to improve your code base. So this is something you can always take into consideration, rewrite your code, and also provide a form of passive learning. For more information, you could you can scan this, learn more about this product, reach out to me, and provide some feedback. So I'm always willing to hear feedbacks. That's it. Thank you.
Awesome. Thank you. Thank you, Caleb. Next up, we have -X.
Hello. Hey, I'm Vivek. I'm building -X. -X is an AI data scientist that uses your analytics tools for you. Let's jump straight into the demo. So this is a plain vanilla notebook that I've loaded up. It has a data set of YC companies that Y Combinator has funded. So -X is a Chrome extension that adds a side chat to your Jupyter. So all you do is you just ask. What -X does is it takes into context your Jupyter notebook, your data set, everything else in the background, and then it actually takes actions that you would take on your Jupyter notebook. So it inserts a new cell, adds code, goes through the errors, if there are any errors, and then fixes it. And then, executes the code and fixes the errors. -X works so this is like a plain translation. So you ask for some things and it gives you things. But so I used to be a research engineer at Comma AI, and I used to have these types of problems. So this is a data set of Anthropic data. And what I want to do here is I want to, that's cool. But what I want to do here is I want to feel lucky. So I'm giving a meta plan. So what -X does is it breaks it down to actual steps that a data scientist would do, which is you would plot some distributions, you would do some correlations, you would go through basically in the loop example, like how a data scientist would reason about the problem to answer your final question, which is, to understand. So it did some correlation analysis. It found out that some things are highly correlated, so it performs a regression analysis, and then it gives you
a timer beeping.
Yeah. So check out -X. We support Jupyter and Metabase and Posthog and more tools soon. You can go install it on your browser and use it today. Thanks.
Awesome. Thank you very much. Next up, we have OneLoop.
I'll start. Hey everyone, my name is Ahan. I'm the founder of OneLoop. Can I get a show of hands? How many of you know about APIs? Amazing. Can I get a show of hands for how many of you know about how to implement API keys? Can you all do that in less than 5 minutes? Well, yes, if you use one loop. Great. So I'll just jump into the demo really quick. One loop is like Auth0 or clerk for your API authentication. What that means is that with one line of code, you can start issuing API keys, add things like permissioning, rate limiting, and also have usage tracking. Let's jump into the code. So here you see it's a basic express. I've got this endpoint models, and right now it's unauthenticated. So I just pass random things, and it still works. So now let me just add like use one loop or one loop auth. Let's let it compile, and there you go. Voila, it's unauthorized. Not just that, we also get the front end. So let's go on a front end. It's literally one line of code. So you create a secret key, and just call it test. Please don't name your keys like that. Copy it, paste it right there, and as you would expect, it would work. Voila. There's more features that I'd like to show, like things like expiration, rolling keys, everything. But the cool thing is we also track usage. So again, one line of code. Remember, just given the value, given the usage tracking you want, and we start showing these components. It's really easy and simple to use one loop. Please check it out as oneloop.ai. And if you have any questions around building your APIs or having API keys, I can get you started in less than 5 minutes. And if I don't, I'll buy you pizza. Okay? Thank you, everyone.
Nice. I feel like you should have called this one line. I feel like you should have called it one line.
If you buy me the domain, I'll rename it.
All right. Cool. Next up, we have Keywords AI. I've seen so many LinkedIn posts from this. I'm so excited to see this.
Hey everyone, my name is Andy. I'm one of the co-founders at Keywords AI. So at Keywords AI, we're basically building Datadog for LLM applications. We make it super easy for you to monitor all of your LLM workflows with 2 lines of code. So let me show you how. Just like we have a timer here, we also build this onboarding speedrun where we also time you on how fast you integrate Keywords AI. It should be under 2 minutes. So you can either use our async logging or our proxy, which basically works with any framework. For example, if you're using OpenAI, it's just 2 lines of code switch. After you send your first event, you will be live with us. You get a nice dashboard that has every single metric of your LLM data. You can filter by a lot of things. Check out different time frames. You can see who your top users are, what the top models they are using. And our most loved feature is our logging system, which shows every metric about your LLM log and their relevant properties. So you can also run evaluations on them to understand if your LLM is hallucinating. For example, in this log right here, it shows that this is very easy to read. So it tells what Keywords AI is. Our users love this feature about how they can bring this log into a playground with a single click, and they can compare 2 models side by side. Let's do another to check out like performance for different models. There's also a bunch of other features our users love. For example, user analytics. Just taking a bit too low because we have too many users, obviously. and some prompt building features. We also have caches to help you speed up things and save a lot of cost. We're Keywords AI. Thank you, guys.
Awesome. Next, we have GoCodio.
Awesome. Hi, everyone. I'm Meg, founder of GoCodio. We are ensuring that developers focus on innovation while we take care of testing. That's our domain, gocodio.com. Let's quickly dive into the demo. So what we essentially do is we go about pulling in your GitHub repository, whatever you give access to. From there, I've picked up Ragus. It's an open source library. Let's go about picking file that we want to test out using GoCodio. I'll be going about looking at Python code because that's where our accuracy is like really high. I'm picking up one of the Python files under Ragus. This is a YC-backed company. It's an open source over there. So what we essentially do over here is we go about generating all the test plans, including your happy paths, your edge cases, and we write it in natural language so that you can take a look at it. And instead of you writing it down manually, we do it using AI. And once you have all of those test plans in place, it's taking a little bit of time because it's creating all of these test plans. So you have these many test plans. The folder or a file had about 300 lines of code, so we have created that. And once you have all of these test plans, you can autonomously create the test cases within your GoCodio page. So all the test cases will be curated by GoCodio for you. We have about 17,000 developers who are using our platform on VS Code and IntelliJ, but this is like a platform that we are launching on Thursday on Product Hunt. So you can go ahead and try this, and happy to connect for any questions. Again, we have the test being written, but yeah, this is how we write it. So all of these test cases, instead of you writing it, we write it for you. And you can directly create a pull request. I've just created a dummy one, and it immediately syncs up to your GitHub. That's what we have. So you can click on this to view pull requests, and this is the test repository. So all of these test cases in your... So yeah, this is where we are, September 19th. Thank you.
Awesome. Thank you very much, Magna. You were not the only one launching on Product Hunt this week. Next up, we have Superflex. Superflex, who is launching on Product Hunt today, who has launched on Product Hunt today.
Hello, everybody. All right, yes, that's true. We are launching on Product Hunt. We're Superflex, and we help you write front-end code 10 times faster. Just by show of hands, how many people here do write front-end code? Okay. How many people here think it's boring and takes a lot of time? All right, cool. You guys should check it out. So what we do is we're a VS Code extension that goes from Figma to code in seconds using your coding style and UI components. So we take inputs from Figma, images, text, and we'll provide you production-ready code that works within your coding style, your design system, and uses your UI components. So as you can see here, this is the code for that modal. It uses your UI components, it creates new components for you, and it matches your coding style. So this is this is code that designers would actually like, which is hard to make. Here's a quick demo. So here we take an image of a modal, gives us answer in seconds. We paste it. It created new components, by the way, that look really nice. So yeah, this is how quickly it is to build features these days. So yes, we launched on Product Hunt. We are Superflex, so you can go to superflex.ai. And if you do have a Product Hunt account, you can scan this QR code and you can upvote if you like it. That's it.
If you don't like it, you can scan that and create a Product Hunt account and then go upvote it. All right. Fun fact, Ibeck last time presented this under a different name. You guys should go ask him why he changed his name later. Next up, we have StackPack.
Okay.
Hi, this is George from Stackpack. Anyone here loves doing DevOps? Okay, only 98% of people hate doing DevOps, of developers hate doing DevOps. So Stackpack is an IDE for regular human developers to do DevOps easier. So what you can do is you can actually write, like import your existing infrastructure, all your configurations, or you can generate something, and we'll do this because it looks cooler. Here we're asking it to create an EKS cluster. So it creates the cluster, follows best practices, it creates like variables to populate the cluster, and it generates 100% valid syntax every single time. It works for Terraform Kubernetes and adding more DSLs, so it doesn't hallucinate with the syntax. And it's even more accurate than Claude. So we can accept this recommendation, and then we can select parts of the configuration or anything, and then ask it to add audit logs. So it added extra resources or like code blocks, made changes to existing infrastructure, and this is something even even if it changed something else, it would just like figure out, okay, you have existing code block and shows you the diff. And this is something even like Claude struggles at doing right. You can accept the recommendation. And then you can create a PR on GitHub. So as an added bonus, you can actually see your code visually and generate documentation. So we just launched this. So please join our Discord, try it out. We'd love to get your feedback. And I also have some souvenirs from Egypt. If someone wants to talk, I can give you some bookmarks. Thank you.
Awesome. Thank you very much. Second to last. Vaibhav, you're not up yet. Don't worry. Laminar.
Hello. We are Laminar. Laminar is a comprehensive observability and analytics platform for LLM applications. Comprehensive means we can track your AI agents end to end, and also we provide a variety of features, including like evaluations, and also we can help you analyze your AI agent on the fly, right, and show you like where it fails. We found that people have like thousands of logs, and they need to extract like the most valuable data out of them. So let me show you how to do it on Laminar, right? So we use Supabase, and I wrote an agent which will go through the Supabase docs and answer your questions, right? And I collect the traces in advance, right? And for example, let's say I want to find traces which show me about how to install Supabase, right? So you can search that on Laminar, and it will show you all the traces, right? Which in this waterfall flow, right? And it will show you my question. I asked it how to install Supabase. And it will show you the output, right? It will say to install Supabase, do this, and that, right? Also, telling about insights, we have this view of events as a dashboard, right? And also you can view events in this way, right? So for example, here it found event saying that my agent fetched URLs which were not present in content, right? So it's I can go to the trace which did it, and I can see that this is where this happened, right? Where this failure of my agent happened, right? And this was the page which it fetched, right? And this was the OpenAI call where I knew the failure mode in advance, right? I told my agent don't add any URLs, not from your own knowledge, right? Because I asked my agent about Tailwind, which is completely unrelated to Supabase, right? But it still added some Tailwind URLs, right? To here. So we help you basically find and spot events like this by building various pipelines which look like this. And also we are open source. If you're worrying about privacy, you can go and start our repo. Also we made one top 3 Hacker News launches in the current YC batch. Yeah, so yeah. And we have a cool tech stack such as Rust, Supabase, ClickHouse. Yeah. So
all right.
If you're interested, Laminar. Thank you.
All right. Our last talk of the night, our last demo of the night is Boundary. I'll give you a fun fact. Vaibhav is also from Seattle. If you guys don't know, I live in Seattle, and I fly down just for these events.
Cool. Cool. We're Boundary. We make BAML. It's a brand new programming language, so dun. But What we're able to do by doing that is we can do better function calling than OpenAI with every model, even models that don't support it. I'm just going to show you demos because I think that's really cool. Here's something we did. We have this form. This is 0 shot, no prompting needed. We can take this form, and hands are off. It's running in real time. And I can pull out all the data out of it in just about whenever the model is done. Oh, that was less exciting. Let me rerun this. This is the... Okay, well, anyway. So basically what we're able to do is with our programming language is we can go ahead and get any data out of any model. And as you'll see, this form has a bunch of checkboxes, has a bunch of things coming out of it. And when it runs, we'll be able to go ahead and, at some point, be able to pull out all the data into a structured data format. And we can do this any sort of thing, audio, video, text, websites, URLs, almost anything you want. We're going to release this fairly soon. But I think the most exciting part about this is if you're ever writing code for LLMs and you're using any sort of framework, one of the hardest things to do is go ahead and build a really good testing loop. So what's nice about building our own programming language is we can give you that whole experience that you want right in VS Code. So can you guys see this? All right, I'm going to try and be really, really fast. So when you write your prompts in BAML, you can go ahead and see this. But the nicest part is you can run everything and actually see the entire prompt in VS Code. Images, text, audio, everything renders right here. You want to see your tokens that you're rendering, you can see them right here. It's like a website. It's like a preview of a website when you write Next.js or JavaScript apps. The second part is you can actually see the raw web request that actually is being made under the hood. Sorry, I scanned past my API key. But what's really nice is when I go run these results, let's just run this test case. I can run my test cases right in VS Code or in CLI. And the reason that we're able to do better than OpenAI is because check out the model. It actually outputted a whole bunch of stuff in front of the model. And I'll stop right there.
By the way, this is recorded, so I can pause and find your API key.
Oh,
all right.
I will rotate.
All right, thank you very much. This wraps up the demos for the night. There is one more thing. Yeah, I saw it work last time. All right. Like I said before at the beginning, there will be another event, similar style, on October 7th. And I hope that you like this event enough that you'll scan this QR code and sign up to come back and tell your friends that they should come back and help grow the community and get everyone on board onto the AI train. All right, that concludes our programming for the evening. We have about 17 minutes, so feel free to hang around, chat with your neighbor, whatever.
In the world of code, dreams begin to flow. Lines and digits glow. Watch these wonders grow. Bright screens light our way.